Alrighty, welcome to the Biomechanics 1 video series looking at the concepts related to torque. So, in this particular video series, we'll look at what exactly torque is. By definition, it is defined as the measure of a force to cause rotation, and therefore it has various applications. It's probably one of my favorite topics to cover because it has so many points of interest. For example, it's often used in exercise to find out how we can tweak and modify various exercises to make something more difficult or to make something a little bit easier. It's applied in the development of various training machines. So, for example, what's the difference between a bench press machine where the pivot point is angled and it plays around with your force application, and how is that different from a normal bench press machine? And also, if you look at various muscles and joints, right? So, why are some joints more inclined to produce greater amounts of force, say, for example, your ankle joint, and other joints, such as your elbow joint, inclined for greater speed but lesser capabilities for force production, right? So those are all things that we will look at throughout this particular video series. So by definition, torque looks something like this in its mathematical format. So yes, it is a vector and is equal to force times the perpendicular distance of force application. So it has this little perpendicular sign at the bottom. So it's denoted by this Greek letter tau, right? And it says that torque, or ability to cause rotation, is equal to the force that is applied and the distance of that force from some axis of rotation. So it tends to look something along these lines. So if I have some kind of object, let's say for example it's a door, that is pivoting about some axis, right? So we'll say that this is the axis of rotation, and I'm applying some kind of force, right? So this is the force that I'm applying, and this force is being applied some distance from this axis of rotation. So that is where this R comes from. So here's that R, and it tells me how far from this axis of rotation this force is being applied. Okay, so there's a couple of things in terms of the dimensional analysis that we have to take into consideration. So what are the units of measure of torque? Well, it's dependent on the units of measure of force and R, which is a length component, right? So we know that in terms of forces are measured in newtons, and distance is measured in meters. So the unit of measure for torque is Newton meters. This is not the same as energy. So in this case, we leave it as Newton meters. It just tells us it's a force multiplied by some distance component, right? Good. Okay. So torque is maximized when it is applied at a perpendicular angle to the axis of rotation, right? So think about it this way. If I had to apply a force in this direction, in essence that's acting through the axis of rotation, and what do you think its ability would be to cause rotation? Well, that's where the three components, okay, 4, 5,